Hello everyone, once again welcome to our channel Physi Dive, and this is your teacher alexi Rajan. Today we are here with a new class for class 11, that is equations of motion graphically. How to prove equations of motion graphically. So without wasting time, let's dive in straight to the class. So here also we are just dealing with three equations of motion, that is V is equal to U plus AT, and second equation is equal to S is equal to UT plus half AT square, and the third equation is V square is equal to U square plus 2AS, and an extra equation, that is Snth, that is equal to U plus A by 2 into 2n minus 1, where n is the time. Okay, so these were the equations that we had dealt, and the previous class we had studied about the equation, how to prove this equation calculus in a calculus method. And those who haven't seen the video, I will just pin it somewhere here so you can go through the video and come back again to this particular class. So here also the basic idea is that how to prove these equations graphically. So before starting, as a prerequisite, I am saying I'm just using a coordinate system, and this is the origin, and the x-axis is denoting the time, and the y-axis, okay, I'll put the arrow mark, y-axis is denoting the velocity. So these are the credentials, basic credentials. Okay, so I'm just saying that the graph is starting from this particular point, and this denote u, and u is nothing but the initial velocity, and where the graph ends, that will give you the v, and which denotes the final velocity, and this will denote the time, final time, and this is the time interval. So we are just taking the initial time as 0 itself, as we are starting from the origin. So you can, it's up to you how to make a graph, how to just take the graphs and all. So these are the credentials, basic things that which we are going to study. In class 9 and class 11 standard, we had studied two types of graphs are there, that is displacement time graph, and the second graph is velocity time graph. So here in this session, we are just taking the velocity time graph to study, to derive these equations. So let us study it more clearly. And the next basic ideas or basic things that which we are getting out of a graph is that from a velocity displacement time graph, the slope of the graph will give you what? The velocity, which will give you the velocity. Whereas in velocity time graph, the slope of a graph will give you what? The acceleration. So this is the thing. And in velocity time graph, one more information you are getting, that is the area under the graph will give you what? The area under will give you the displacement covered by the object. So those who want to study it more clearly, you can once again go to the 9th standard or the 9th standard video that I will pin it somewhere here, so you can just go through and find out how this area, how we can get the displacement by finding out the area and all. Clear cut informations, each and every informations are taught and explained in that particular video. Okay, so these are the basic things. And a straight line graph will give you which graph? Velocity time graph will give you that it's a uniformly accelerated motion. Uniform, all the four equations are dealing for which type of movement? A uniformly accelerated movement. So that's why you're getting a straight line. Okay, these are the basic ideas of a graph. So without wasting time, we'll just deal directly to the first equation, V is equal to U plus AT. So let us see what happens there. Okay, just imagine that there is a graph in your hand, and you can see there is an origin O. Let us point this way, this as, okay, I'll use different color. This is A, this is O, and let this be, okay, this value, this is what? The final velocity V, and the corresponding value for the V, the time is T. Okay, if I want to find out the acceleration, so acceleration is what? It is a slope of velocity time graph. So how can I find out the slope? So slope of a graph is denoted by the tan theta, and here tan theta is what? Tan theta will be equal to BC by opposite by adjacent, that is AC. And here you can say A is equal to what? BC. BC means what? This value. This value is, this total value is V, and this value is U. So if you subtract this value, then you will get this BC. So you will get V minus U by What is AC? What is AC? AC is nothing but the time. The time interval is nothing but small letter t. So A is equal to V minus U by T. If I am finding out the slope, then I'll get V minus U by T. From there, you will get AT is equal to V minus U. From there, simplify that thing and V is equal to U plus AT. Here comes the first equation, that is V is equal to U plus AT. The only thing is that you need to find out the slope of the graph, and slope is nothing but the tan theta, and tan theta is BC by AC here, and BC is nothing but the total final velocity minus initial velocity, and AC is nothing but the time interval, that is nothing, it is the t. And from there, substitute the values and you will get the values. The final equation, that is V is equal to U plus AT. So what about the second equation of motion? Let us see. Now, in the second equation motion, you need to find out S is equal to ut plus half AT square. How can I find out this? Using this particular graph which is in your hands. So here you already know that the area of the graph denotes what? The displacement made by the object. The area is this shaded portion. Okay, you can see a shaded portion here. If I'm just taking this shaded portion alone, you can see that this will be the shaded portion. Okay, this will be the shaded portion, and this is a trapezium, right? But here we are going to find out the area by just dividing this trapezium into two halves, that is one triangle and here one rectangle. So this will be the total area covered by this particular graph. Okay, you can see this, I'm just taking this shaded portion here separately. Now the area will be equal to area of triangle ABC plus area of the rectangle OACD. So what happens there? Area is equal to area of triangle is equal to half into base. Base means AC into height. Height means BC. Okay, plus area of a rectangle, length into breadth. So OD into AO. Okay, so this will be the case. So OD into AO is the rectangle's area, and half into base. This is the base. This is the base. AC into height. This is the height. BC. So let us see what happens there. Half into, what is AC? AC is nothing but the time t. What is BC? You can see there BC. BC means this total length is V and this CD is U. If I'm just subtracting V minus U, then I'll get the remaining portion BC. So what happens there? So it is V minus U plus OD. OD means what? It is again time there into AO. AO. What is AO? AO is, it is the initial velocity. This is the initial velocity. So you can say UT. So from there, again I am rearranging. I am taking these terms first, and so UT plus half into V minus U into T there. So what is this V minus U? Okay, in the first equation of motion, you can see that V is equal to U plus AT. From there, V minus U is equal to what? AT. Substitute these value here and you will get area of the triangle is otherwise the displacement. So I am just writing S is equal to UT plus half. Instead of V minus U, I am just writing it is AT, and one more T is there, so AT into T. So you will get the final answer as S is equal to UT plus half A T to T, so T square. From there, you are getting the second equation of motion, that is S is equal to UT plus half AT square. Simple as that. Okay, you can just find out the area, just separate that area into two areas of triangle and area of rectangle, and then you substitute those values there and you will get, using the first equation, you again a small substitution is there, and then you will get the final equation, that is S is equal to UT plus half AT square. So here comes the second equation of motion. Now, what about the third equation of motion? So again, the same scenario, that is the initial velocity is given there, final velocity is given there, the time is given there. This is a time interval, so small letter t. So here are the various points there, O, A, B, C and D. Okay, so we can see all these things there, and you need to find out what happens here, or V square is equal to U square plus 2AS. Here also, again, we are just taking the area of the graph. Area again the area there, area is equal to the shaded portion. Here you can see the shaded portion there, right? So if I'm just taking this shaded portion separately, I will get a shaded portion like this. I'll get a shaded portion. So here in this case, we are just taking this shaded portion as a single area. That is, this is what? This is a trapezium. So area is equal to area of trapezium there, right? And area of trapezium is given by, so what happens here? That is half into sum of sides. Parallel sides means here AO and BD. AO is what? It is nothing but U, and BD means V. So U plus V into what is the distance between this parallel sides AO and BD, and that is the two perpendicular. This is a perpendicular distance, that is into OD. So here that is equal to half into V plus U. Instead of this time, again a small substitution is there, that is V is equal to U plus AT. From there T is equal to V minus U by A. Okay, substitute these value here instead of this T, and this T will become V minus U by A. From there, you can say that S is equal to V plus U into V minus U by 2A. A plus B into A minus B is A plus B into A minus B is equal to A square minus B square. From this form, we can get this value, that is V square minus U square by 2A is equal to S. From there, substitute, rearrange, and you will get V square minus U square is equal to 2AS. From there, V square is equal to U square plus 2AS. So here comes the third equation of motion, that is V square is equal to U square plus 2AS. Here the only thing is that you need to find out the area of the trapezium, and then you will get in this particular form, that is V square is equal to U square plus 2AS. Here a relation of velocity and displacement is found out, and you will get this particular equation. So I hope that you got the point there. Simple as that. Okay, now the last equation. So how will we get into that particular equation? Let us see that equations too. Okay, that equation too. Okay, so to that particular equation. Okay, now the last equation of motion, that is S nth. If I want to find out the S nth, then that will is given by U plus A by 2 into 2n minus 1, where n is the time there. So here in this graph, you can see that how will I find out this S nth? So simply the basic logic is that S nth, at the nth second, what is my displacement? So my displacement will be Sn minus Sn minus 1, right? From the previous class, in the logic is clearly given in the calculus method. How in that particular equation, I had just briefly or explained clearly about how we come to this particular idea. So please go through that video also. I'll pin it somewhere here. You can just go through that. Okay, Sn is equal to Sn minus Sn minus 1. So from here, what is Sn? What is my Sn? Sn will be this shaded portion. Sn means the body had reached this much. So this is the nth total area. Sn minus 1 means this is n minus 1. So the graph, the area of the graph till here, this particular point B, shaded portion, right? Okay, so you can see that here the total area minus the second portion, that this portion, will give you the remaining portion there. That is, the remaining portion will be equal to, I'm just writing it separately so you can get it. The separated portions will be like this. That is, it is given by. So if I find the area of this particular, if I find the area as E, B, C, D, then I will get the value for this S nth. So let us see what happens, or what is the value of this particular remaining portion. Area is equal to, there also one trapezium is formed there, area of trapezium EBCD. Let us see what happens. So that is equal to half into, what is EB? So you can see that EB is nothing but it is the velocity at n minus 1, right? This is V at n minus 1 time. So let us see, that is V n minus 1 or U n minus 1 plus, what is this DC? DC is the total time, that is V n. What is the velocity at time? N. So V n minus 1 plus V n into, what is ED? ED. Okay, you can see this is the remaining portion. ED will be equal to n minus 1. So this will be the case. That is area of trapezium is nothing but Sn, and that is equal to half into. So what happens there? So the first equation goes like this. Instead of this Vn minus 1 and Vn, we'll write in a different way. That is, only u term is there, right? So we'll just convert that thing into u. So we know the basic equation, the first equation of motion, as v is equal to u plus at, and Vn minus 1 is equal to u plus a. Instead of t, you can write n minus 1, and Vn is equal to u plus a n. So this is the thing, right? Okay, let us see what happens there. So now you can say this is equation 1, equation 2, equation 3. Okay, substitute 3 and 2 in 1, and you will get a wonderful result there. What happens there? So Sn is equal to half into u plus a n minus a plus u plus a n. And if I'm just taking the a outside, so u plus a by 2 into 2n minus 1. So this is nothing but the last equation, that is Snth, that is u plus a by 2 into 2n minus 1. So here the only thing is that you need to come to that particular form. Okay, by here, from after reaching this particular equation, almost everything is over. That means your mathematics, your physics is over there, and the remaining part is your mathematical ability to just turn this equation to this equation. So you need to know that only u term is there, so you need to substitute that v terms in term of u, the initial velocity, and that we will get from the first equation, that is v is equal to u plus at, and from there you substitute Vn minus 1 and you find out Vn and substitute the values, and you will get Snth value, that is equal to u plus a by 2 into 2n minus 1. So that's it. So I hope that you got the points and you got the equation. I hope that you know how to derive these equations, all the 4 equations graphically too. So till then, we'll just practice those equations and understand it more thoroughly. And now we need your support in terms of your like, share, comment, and subscription. So till we meet again in the next class, goodbye and have a nice day. Goodbye.